Cool, thanks, Madeline. Welcome, everyone. Thanks for joining. This is part 2 of the 3-part series this morning of the new way to conceptualize, design, and build a stadium. The first part, I think, was absolutely brilliant. Thanks to Andy and Mo on the call. Really great insights into Everton. This is going to be a little bit more detailed and technical, so apologies for that in some respects, but we're going to kind of strip back some of the layers and how we achieve some of those things. So I'm Rob May, a director in our sports and entertainment structures at Buro Happold, and also on the call we've got Mo from Everton. Hi Mo. Senior Liaison and Engagement Manager.
Hi Rob, apologies, we've got a fire alarm going off every, it's just a test, but it's, so I've had to put myself on mute.
Cool. And Nick Tyrer, an associate at BDP Pattern, architect involved in Everton Stadium. Morning, Nick.
Hey guys.
So brief overview, introductions, and then the pace of design. Why rapid prototyping? Why we're kind of looking at doing things differently? What do we mean by rapid prototyping in the AEC? Because it's not a new term that we've invented. Briefly then, sort of building configurators and what we kind of mean by that as an evolution of rapid prototyping. Then some rapid prototyping examples, and then into a bit of detail in Everton Stadium. And Nick's got some great slides and insights around the design of Everton Stadium. So a little bit about Buro Happold. I'll whiz through these because I'm sure a few of you were on the first part. We're an international company, Buro Happold. These are the offices, locations that we've got globally. An independent practice for over 1,900 staff working in the built environment. And these are the regions in the world that we operate in. We work in various sectors, so this is all about sports and entertainment today, but we also work across all of these other sectors as well. And we have a good number of specialisms. As a structural engineer, there's definitely a structural engineering kind of bias to this presentation, so I apologise for that. But we do a number of different specialisms within the practice. We are interdisciplinary, and we truly do work together incredibly collaboratively, both internally and with external collaborators, and we're very passionate about that. And hopefully you'll see some of the approaches that we're developing here speak to that in terms of connecting specialisms together. So before we go digital, always kind of like to remind ourselves and everyone that, you know, design isn't just about sort of creating 3-dimensional models and data. It starts with an idea and quickly followed by sketch and discussion. So a lot of the stuff that we're talking about is really facilitating design and facilitating the, achieving the outcomes that we want. The pace of design is just ever increasing. We get smaller and smaller amounts of time for it for various reasons. The kind of rebus stages often can get a little bit blurred in that respect, especially when we're going for kind of fast track programs, and that in turn then compromises project outcomes and ultimately the performance of the design. So we're needing to develop ever faster ways to test and validate designs as we're going through in order not to compromise the outcome. So how can we do that? How can rapid prototyping facilitate that? How can it facilitate informed decisions from feasibility through to construction? This is kind of a very sort of classic diagram of rapid prototyping that would be applicable to kind of anything, not just stadium or building design. And you go from brief specification, and then you build a prototype of the thing, you review it, you refine and iterate that prototype and go round and round the circle until you get out the other end your final product or your final design. And it works really well for relatively small scale things. This is a Dyson Hoover, and naturally you can kind of 3D print or create wooden prototypes of products that are small enough to fit in your hands so that you can test how they feel, what the weight is. It starts to become quite difficult at the building scale, although we do create three-dimensional prints of parts of buildings, and these are just a selection of some of the bits and pieces that we've printed from different parts of buildings. Scale is a bit of an issue, and so this example on the right-hand side is great because we've got a 3D printed person next to this huge piece of steel, but it's not really telling us anything beyond that. It's not as if we can test this small scale model for how strong the steel is because it's not scaled. And so 3D printing and rapid prototyping in the sort of wider sense isn't actually the complete picture we need for buildings. And there's therefore a lack of performance-based design. We can't test the 3D prints. You can see on the lower left, that's actually a wind tunnel test model of Everton Stadium. And that's an example where actually the physical model is something that we put into a wind tunnel, blow wind on it and see what the wind pressures are. So it's not that 3D printing isn't relevant, it's just it doesn't show the complete picture. And that's Everton Stadium there. And what really we're talking about then with rapid prototyping is how we quickly test a design against a series of outcomes. And there's a series of outcomes here, very simple ones for the roof, you know, the sunlight that you get on the pitch, the view through the roof, the wind on the roof, and then the weight of the roof. And so those are the really things that we need to drive when we're talking about rapid prototyping. And it's not a simple equation. So, you know, covering more of the seats for rain means that you reduce sunlight on the pitch for grass growth, for example. So it's not a simple equation to solve. Therefore, it needs to be something that has multiple representations. There are various different analytical models and processes that all then need to fit into one thing to give us a virtual prototype, as well as then the physical representations. They all give us a small piece of the picture. Building information modeling then, could that be our rapid prototyping platform? We create ever more complicated building information models that go all the way through to construction. We get our drawings out of here and the details, and you know, if you look at any of the stadium models that we've got, they're incredibly complicated. The challenge with that is they're typically very heavy. They're associative, so everything kind of connects together. So it makes it quite difficult to rapidly create this level of detail, pull, push, and change. And so these are really suited at the later stages of a project where the level of change has settled. So how can we then rapidly prototype? If we then take the spider diagram from before and we plug that into essentially a database of data and analytics, and then plug in all of the different models that we need to simulate the building, whether it's the structure analysis or the energy analysis or parts of the facade that need to be analysed. We plug those all into a database and effectively within there connect these different outcomes together and allow each one to influence the other, then in order to get the best outcome for the project and to optimize this diagram so that we're close to the outside and balanced all of those objectives. Where does that sit on the design spectrum? When you start out with a kind of rapid prototyping process, it's almost a blank sheet of paper and there are unlimited options. As then you develop a series of designs and bring in boundary conditions, you end up constraining things to the point where you're now getting towards something that can be built or that is a final design. And there's some point along that journey where you've ended up with something where the level of change is really just configuring a design rather than creating a whole new set of different rapid prototypes. What that looks like in terms of options then, if this was a timeline, you start off with essentially an infinite number of options for the stadium. Could it be timber? Could it be steel? What capacity is it, etc., etc.? you apply these rapid prototyping principles and test each one of those iterations to the point where you're getting down here where there are fewer options until you get right to the very end of the design process, and you effectively end up with what you could call a digital twin, which is the BIM model, and something that then can be taken for construction. What does it look like then, that rapid prototyping piece? This is a sort of generic building showing overheating analysis, and that then overheating analysis is plugged together with a whole series of other analyses in the background. That plugs into, as I said before, a database so that you can see all of the results of those different analyses, and you can start measuring those against the desired outcomes. So the charts on the right hand side here, you'll see various options are threaded together, and not one of them has optimal, 100% achieved all outcomes, but you can see and navigate which option has met as many of those objectives as possible. We often have a bit of fun with this, and so this is then a stadium version of the same rapid prototyping process. And this is actually a Google Hangout. You can see, I think there's 10 or 12 people connected to this, all doing different parts of the analysis of the stadium, but feeding into a central model. And each one is kind of responsible for, say, the structure. One is responsible for the roof cladding. One's responsible for the seating quality. And everybody is basically changing and updating their design. And then each time, then each iteration, we're getting a new version of that spider diagram so that we can start really assessing against the performance criteria. When I talked then about building configurators, taking that one step further, and this is something that's starting to kind of resonate in the industry. You guys may or may not have heard the term, and once you've got through that process of having an infinite number of rapid prototyping prototypes, and you've reduced down the number of options, you end up, as I say, with something that you might change the connections, you might change the floor finish types, you might change the color of aspects of it, and you end up with something that is more like a configurable design than an unlimited number of options, thereby only having a few options that you can configure. One then again sort of analogy to that is that people often make is the sort of car industry, where there are configurators, and this is the Tesla website. This isn't me buying a Tesla, but this is me just kind of clicking through and looking at the different options here, changing the interiors, changing the colors, etc. Why this is different to buildings is in a lot of respects, buildings are a lot more complicated. At least the number of things that you might want to change and configure on a building are almost infinitely more complicated. And the number of systems and the procurement is very, very different and quite difficult. And so configurators, I do think, will look quite different for the building industry than they do to the automobile industry. What might they look like then? This is a very quick kind of prototype of a relatively small capacity stadium, showing some very simple parameters of changing the seating layout and the structural grid and the roof angle and the roof topology, and getting simple metrics like the cost or the weight of the roof or areas of different things. This is only a portion of the model that's shown on the screen, but you can start to see them once you constrain down from an infinite number of options to a stadium scale, a particular set of roof topologies, you can start to move in the direction of the kind of Tesla configurator. Again, I don't think you'll end up all the way at Tesla configurator, because I don't think that there'll be one stadium design that everybody kind of sticks to and they just change the color of the exterior or the wheels, so to speak. And we are doing a bit more work in this area. This is a snapshot of some work that we're doing with the UK government. It's a government funded project to look at, in part, how do we create configurable buildings and configurable parts of buildings. So breaking things down into a kit of parts and then being able to pull those together into a building and then get live metrics, the embodied carbon of the building, which is really, really important for us to measure the tonnage of the building, the cost, and etc. And we're in the early stages of this, but it's looking quite promising in creating a framework for these configurators to allow then this to plug into more complicated, including stadium configurators. So a few examples then, what does some of this look like as an output? Roof structures. For a long time now, internally, we've been developing, and as an industry, our capability in creating parametric roof structures. And so one of the biggest cost items on a stadium is the roof structure, by the nature of it being long span and typically quite a lot of steel or timber. And so then the ability for us to really, really quickly model those and test them is something that we've been doing for some time. And we're at the stage now where, and this is my colleague Al Fisher and Arnaud, playing with Education City Stadium roof, which Nick and the guys at Pattern did with us. And here Al is basically in the virtual reality environment, and he's sat at the top of the stand, and he's saying, hey, the roof structure is too low. I'm not going to be able to see the ball when it's kicked to above what we call the high ball line. Can you please pick the roof up? And Arnaud is then duly moving the roof up, and in the background the structure is recalculating itself to give then the updated quantities, the updated tonnage in an approximate sense, because this is early stage, again then to feed into the overall picture, the overall building prototype, to say, this is what the roof profile could look like, and it meets some particular constraints. When it gets then through to construction into the same project, Education City, we often then take those rapid prototyping models and add a construction layer to them. And it's quite an innovative cable net roof, gravity cable net roof for Education City. And what we're doing here is basically showing that rapid prototyping model, animating how that roof gets constructed. And this was instrumental in the early stages of the project in us facilitating this cable net option, because the contractor at the time wasn't familiar with this type of construction and was concerned about moving away from a much heavier roof. So on seeing this, a penny dropped, and they were very, very pleased to move forward with the cable net roof solution. And so again, a part of the rapid prototyping process is bringing clients and contractors along the process to explain the implications of some of those decisions as early as possible. A huge part of what we're doing at the moment, and what we're needing to do moving forward now, is make use of existing buildings and existing assets, so that we can reduce our carbon footprint and the impact we've got on the planet. And so we're increasingly now looking at and have quite a long history of looking at existing stadia and venues and upgrading these. We've started applying these tools to those existing assets. And you might think from the previous slides that all of this is very difficult to apply, that's something that exists, because it's very easy to create a new building or a new structure or a new geometry from nothing. But our process is essentially bringing in as much information as possible into that computational model about the existing building. And it might be from an image on Google Earth or something to begin with. And actually we start prototyping things from the smallest amount of information. As we get more information, whether it's a site survey or a set of photographs or a set of drawings or a model, we feed those into the rapid prototyping model so that it becomes more and more accurate. Along that time then, we're always analysing it for what kind of new roof would fit on this, how would we modify the existing bowl, can we fit a new number of seats in there, and so really testing the existing asset with all of the changes, the proposed changes and options that we might look at. As Andy talked a little bit about on the previous presentation, we've also started turning these tools to benchmarking of venues. And so this Cardiff Arena bid that we did, we compared Cardiff against two other arenas, Motorpoint and Ziggo Dome, in order to explain the relative benefits and merits of a new venue to the city. And using the venue performance benchmarking that we've developed, an evidence-based system to take what the project outcomes are, whether it's the sustainability of the project or whether it's the operator requirements or the fan experience, put that into a numerical construct that allows us then to score one venue against another. What that lets us do then is start quantifying, with all of the metrics and data behind it as is when requested, how one venue performs against another. And so then that allows us to effectively compare not just different venues, but also different options for the same venue. So all of the sort of previous slides on looking at different design options, we can turn this kind of analysis of how good is one option against another by using these, what we call composite parameters of lots of different metrics of what good looks like, and measuring one option against another. So with that, I will hand over to Nick to talk a little bit about BDP Pattern and how they use rapid prototyping.
Yeah, thanks, Rob. So I suppose first just say that BDP Pattern, we're sports and stadia architects based in London, and we've recently joined forces with BDP. So this is a fairly new name. We've delivered stadia around the world, including 2 World Cup stadia, and have worked closely with Buro across a number of these projects, Education City that Rob mentioned, and Everton's new stadium. And Rob has mentioned, I'd say, most of the processes and ideas kind of in this topic. I just wanted to quickly hit on a few points of kind of from the architect's kind of perspective, kind of how we feed into this as well. So I suppose the first kind of big idea is just the idea of complexity. We need to embrace it. We develop our own tools basically to ensure that we are not limited by the tools that are available in the market. And so we create our projects as kind of holistic computational systems where everything is connected, everything is reactive, and from the bowl, structure, lighting, and everything's flexible. And I suppose from one aspect of this is the speed that this allows us to proceed through projects, as Rob mentioned. But for us, it's the creative freedom, being able to, whatever the idea is, whether this is some fractal roof of a stadium in Canada, that we could go through hundreds of iterations and quickly test all these different systems through that. Next slide, please. And then another key metric in a stadium is obviously the bowl performance. The sight lines and experience are fairly subjective matter. It's questions of human experience. How is atmosphere generated? There's not really a single metric that defines this. That there's lots of different ideas of what generates a good atmosphere, and so we try and measure all of these different ones, and again bring them together to make kind of a hybrid performance. And any small tweak to a bowl will have any number of unknown consequences, that one metric will get significantly better and another will be kind of worsened. And we work with the club at early stage, trying to understand their priorities. What do the fans expect? What do the fans kind of, what's in their blood, essentially, as each club is different. Next slide. And something obviously that's been recently a hot topic, that is the socially distanced capacities at stadiums, making social bubbles, how to make sure clubs can get the most out of their stadia while meeting the socially distanced rules. So we've been working with a few of our clients to develop these kind of interactive tools. Next slide. Okay, Rob, this is you.
Yeah, so Everton Stadium, I've got a couple of slides on it, and then Nick's got some really cool ones afterwards. Yeah, so Everton Stadium, working with BDP and together with Mo, awesome new stadium, and we've employed a vast number of the tools that you've seen above on the stadium from the early stages. Some of the key ones being egress simulation modeling for crowd dynamics, the Eastern Fan Plaza in particular, making sure that the crossover points and all of the egress from the stadium into those areas works. And again, this is something that feeds into that overall picture, the overall where the stadium sits on the site, how that impacts the structure, the foundations, the relationship to the dock wall. This is just one of those metrics that fits into that. One of the key ones for structures and structural engineering is the roof, and we're only showing 2 options here of many options that we looked at for the roof structure. And the 2 options here are the one on the left is essentially a similar version of what the roof will be in a diagrammatic format, and the one on the right is a cable net equivalent. And so typically one of the most efficient structures to put over a roof, a long span roof, is a cable net. But in the case of Everton, the geometry is not quite what it would need to be to make the cable net as efficient or buildable. And again, that sort of complex series of reasons why one is better than the other doesn't quite make it relevant or the best solution for Everton. Underneath those 2 images there are a snapshot of the embodied carbon dashboard that we've got. So looking at the amount of carbon that each one of these options would produce is a key metric in whether what option we take forward. And so again, the tools allow us to look at these really quickly. Historically, to do this in any level of detail was very difficult quickly, and I think what it's enabled us to do is look at many more options, put those on the table, but also with some metrics against them so that we can better quantify them. And over to Nick for the facade.
Yeah, so I know the next presentation goes into DFMA in more detail, but just quickly hit on the facade. So the base of the stadium is inspired by the local brick warehouses that fill the area, and they're made up of these series of kind of semi-random brick pillars with the Leech Truss from Goodison Park emblazoned on the side. And part of the conceptual idea was to create this basically not a repeating pattern, and obviously non-repeating patterns aren't amazing to build. And so part of this kind of process was ensuring a semi-random kind of a controlled randomness, making sure it can be delivered and it's buildable. So if you just can get to the next slide, Rob. So this is the kind of the data that sits behind the facade panels in terms of these precast concrete panels with the bricks. We've got 745 different panels that are being fabricated by Laing O'Rourke, with a total of, I believe, over 500,000 bricks. And so you can see the numbers very, there's such a huge quantum that creating these rules to manage the data is vital. Next slide. And then I think one of the more interesting aspects of the whole project at the moment is essentially the wind on the site. So anyone that's been along the riverfront in Mersey, it's an amazing location for a stadium, but it does have its own challenges. The intense wind coming from you can see at the left of the image there's the North Sea, and we also have a wind coming up from the city as well. So lots of different wind directions create a very difficult challenge for making sure that the site is not only safe but comfortable for 50,000 spectators that are going to be coming to a game come rain or shine. So next slide. So this has all been done with Buro Happold computational fluid dynamics to simulate the wind conditions, to analyze different scenarios. And if you go to the next slide. And on the west side of the stadium, the side facing onto the river, we were in a situation where we're dealing with essentially the worst of all the different wind conditions, and how do we make a stadium that is an amazing experience for spectators, while also having all the necessary wind mitigation devices. And we went through with Buro Happold, I think 60 different iterations each that was tested. So you can see, different ideas from changing the breakdown of the building, changing the shape of the building, trees, wind baffles. What we found was that because the conditions are so challenging and from different directions, is that one solution would work fantastically from one wind direction, but then when the wind comes from the reverse, it has the absolute opposite impact and actually, catches them. So each of these iterations were analyzed, and we learned something each step of the way. Next slide. So on the left, this is the analysis produced by Buro Happold of just a single iteration. So each of those 60 different versions of design, this is 9 different wind directions. And you can see just from the analysis, without even knowing what the colors mean, the results are vastly different depending on where the wind's coming from. And then on the right is, as Rob mentioned earlier, the physical wind tunnel model, that after the computational fluid dynamic models are run, it's all verified through a physical model in a wind tunnel that kind of gives the next level of verification, essentially. And next slide. And through this whole process, we worked closely with both Buro Happold and Everton. And one of the fantastic things with working with Everton is that they've really embraced this process and have actually, rather than kind of opting for the simplest and smallest solution, they've opted for the solution that's created public space. And the outcome of this kind of wind tunnel CFD analysis process is this West Terrace structure, which essentially protects all the entrances on the west of the stadium, but it creates this grand elevated platform that faces out across the river. So, on a nice day, this whole area can be full, and there's a ceremonial drop-off point for the players in the middle where they enter into the building, where everyone can be spread around on the banks of the Mersey. And then obviously on a cold, rainy winter evening, if the wind is too extreme, the gates can be closed. This area can be managed. It can create a really safe, comfortable space inside for all the fans. Next slide. So yeah, and this is just that shot of that West Terrace that's facing out onto the Mersey. That's me, Rob.
Cool, brilliant stuff. Really, really good. Thanks, Nick. So we've got a bit of time for questions, and we've had a few through. I think there's one perhaps for you, Mo, if I may. Would there be potential for clubs to use this technology and prototyping to allow fans to contribute to the design of a new stadium? Perhaps in a similar way to how the audience was able to input into the design in last year's presentation. So yeah, how might fans engage with all of this, do you think?
Yeah, I mean, as I said before, that process kind of continues, really. We've obviously we've kind of got to this point through kind of fan engagement and fan input into the designs through the consultations and the focus groups that we've had. And that process will continue as we head towards the internals of the stadium as well. So we'll be engaging supporters to understand the fan experience that they would like to have within the stadium, and that will influence what the stadium's going to look and feel like internally, as well as what happens externally as well. So we've talked about the fan plaza that we've got and the giant kind of fan area that we'll have. So supporter input will be absolutely huge into what happens and what goes in there, and what that looks and feels like.
Yeah, I suppose just to add to what's Everton of the public consultations and the engagement that's been happening with fans has been incredible to be part of. One of the aspects that I most like is the community. You've set up the VR goggles, you've set up the projector rooms where you step inside a 3D virtual version of the stadium, and all the way through there's been so much feedback that's been fed through to us, and that has been really embedded into the design process.
Yeah, absolutely. And you know, there were comments from fans quite early on about wanting a nod to kind of Goodison, and for Goodison to be kind of represented within the stadium, and the Archibald Leach kind of architecture there that you can see on the facade of the stadium is a real kind of you know, is a positive kind of symbol of that. And something that fans have loved and kind of engaged with. You know, we had a few fans asking us if we could actually take the actual Archibald Leach trusses from Goodison and put them into the stadium, but that's actually a bit more complex than it sounds, bearing in mind that I've been there for the best part of 100 odd years and may look great on as a facade, but are rotting from the timber perspectives kind of behind it. So, you know, there are challenges to kind of maybe taking every kind of suggestion on board, and what we try to do is take as much of it on board as possible, and listen to as many supporters as possible. And I think the next steps for us are kind of the fan experiences and how we can mould and kind of get them right. And we've got a lot of data on that already from the initial surveys that we've done, and we'll continue to kind of engage with supporters on that and try and understand how we can ensure that we have a kind of a fan experience that suits everybody, with the wide and disparate fan base that we've got.
And I guess through operations as well, when it's actually getting a sort of data rich kind of feedback of how people are actually engaging and enjoying or commenting or etc. can kind of feed back into some of these processes as well.
Yeah, absolutely. And I think one thing that, you know, gets considered throughout all this is that at the moment there's probably, you know, the best part of 100 years worth of kind of match day tradition that has been passed down from generation to generation to go in the game, and some of that tweaks and changes, and you know, people go to different pubs and all that kind of stuff, and people's match days begin to change. Here we're kind of, everyone's match day is changing, everyone's kind of routines are changing, and it will take that little bit of time for people to find their routine and where they go before the game. Some people will choose to go into the city centre because it's really close to kind of where the stadium's going to be. Some people will choose to maybe get into the stadium a bit earlier because there'll be concourses and bars and food and drink that maybe wouldn't have been available to them at Goodison previously, and allows them to get in and watch the warm-up and soak in the atmosphere and that kind of stuff. And there'll be others that will maybe want to kind of experience the fan plaza and the fan zone and what that offers. Plus all the new bars and restaurants and pubs and the accelerated regeneration that this is going to provide, right from the city centre all the way up to the new stadium, the new experiences that's going to create. So it'll take that little bit of time for people's kind of match day experience to begin to form and create their new traditions around a kind of a new stadium, which is actually quite an exciting thing to kind of think about, really, because, you know, this is people's routines tend to get set in stone, don't they, in terms of going the match. They'll have a pub that they would frequent, or they'll go to a certain chippy beforehand, or meet friends at a certain corner of the stadium. All that will begin to evolve and change. It'll all happen at the same time.
Yeah, no, it's making me really excited to come. Hopefully it's finished. Cool. There's a question I think may be good for you, Nick. What examples can you show of successful options to help inform cost? And linked to that, in gamifying, how do you constrain the time spent on options to attain solutions?
Wow. Okay. So in terms of cost, I think it's different project to project. We kind of focus at creating, as architects, obviously, I kind of wear two hats in the office. I've got my computational hat and I've got my architect hat, and they may be at slightly at odds, where one side of me wants to invest in the systems and invest in kind of really dialing into the minutiae of the data and making it kind of repeatable, whereas the other side of me wants every project to be different, to be wildly different, to start fresh, clean sheet of paper, what's the idea, and then kind of go into it. And so how we've set up the office is that we essentially have lots of little tools that we create and that we use regularly, and then for each and every project we approach fresh, and so that it's maybe not the most efficient way all the time computationally, but it does mean that we're able to be really reactive to each unique situation and client. And so in the past we've worked with QSs to actually embed their data into our model, in terms of when you're testing different stadium ideas or designs, there's lots of things that change that are not that obvious. So you might say that how much does it cost to add 5,000 extra people into a stadium? And you might think, oh well, it's just 5,000 extra seats, but those 5,000 extra seats are at the top of the bowl, which means however big the bowl is, you're adding another 4 meters of height onto a building, you're making the building wider, it might be in 4 or 5 stories up, it makes the roof longer, and so there's a while yes, it's 5,000 extra seats, it's what's the changes in the span of the roof, what's the changes to the area of the facade, and so all these are things that are quantifiable and that we can take out. And so we've done that before. We sit in workshops with the client and we essentially say, oh, do you want to go more this way? Do you want to go more that, is it potentially increasing the hospitality, or and we rely on our kind of data that we've built up on cost modeling to be able to feed into those conversations. I suppose, could you just remind me the second part of the question? Was about the gamifying?
I think in gamifying, how do you constrain the time spent on options to attain solutions, which I think you started talking about.
I suppose I'd say it's maybe a lazy answer, but it's very subjective. Sometimes you can go down a rabbit hole of making sub option after sub option and extra data, and it really isn't required on a project, and other times it can be vastly rewarding, and it can really push a project forward by having those options. So I'd say unfortunately it's putting a finger in the air and having a feel for what the club's needs are, what the fans' needs are, and the way that the project is moving.
Yeah, and I think if I could sort of answer and relate it to another question around how do we assess options against client requirements? I think we have from Everton and various clients, then it comes through discussion, it comes through and through the fan engagement and exactly what is this kind of asset required to do. It's up to us then to convert that into some kind of numerical model, or put it into our design process to convert that into what the design actually is. And I'm always amazed actually at the butterfly effect of some of those changes that we make. Actually really could be a small change. And actually I remember on Education City Stadium, Nick, in the early days when we dropped the overall height of the building, oh great, this floor's got a bit too much height, so yeah, brilliant, we'd save this much money on the facade. But then the knock-on effects of that in terms of the services coordination and everything else, they're kind of huge. But always then measuring that against what the overall outcome is. Cost, fan experience is really, really important. And I personally feel that by sort of, if you could say, gamifying or using these rapid prototyping processes, different to before, we've got these really kind of detailed models to assess what that butterfly effect is. So if you push this little bit here, that bit over there kind of has changed dramatically, and I think that's what this is kind of facilitating us to do.
No, definitely, and I think kind of goes in, there's an element of it which is almost risk avoidance, or knowing that butterfly effect, say on Everton, as we're looking at it on screen, the site is so constrained, you know, it's such the tight to the boundaries of the site that we really have to be careful of that butterfly effect, and we have to know, you know, if we're going to make changes, that we can live with those consequences, and we don't find out you know, in 6 months' time that there's a problem that we can't get over. Yeah, so I think in a way it's been very productive, this kind of the process on Everton, making sure that we meet all the various demands of the brief and the site and the clubs.
Cool. We're a little bit over time, so I think it's probably a good time to wrap up. And up next, our Joe Darcy with Lang O'Rourke is going to talk about almost the next level of detail of this, and design for manufacture and assembly, how we convert everything that we've talked about here into pieces that can be brought to site and erected. So thanks so much for joining and contributing, Nick and Mo. It's been really good, and I'm really excited about coming to Everton.
You're more than welcome.
Thanks, Rob.